Welcome back. In this lecture, we will look more deeply into selection control statements, which is one of the categories of control statements. Do you remember all three categories of control statements? Try to say them out loud if you do. That's right, sequential, selection, and repetition. I'm pretty sure I drive my face-to-face students crazy with memorizing and practicing, but many of them have come back and told me that they got jobs because they were able to articulate how different programming constructs work and what they are for. So it is important to be able to communicate and discuss programming as well as being able to create practical code. Back to selection control statements. In C++, there are three syntactical varieties of selection control statements, which are the if statement, the if-else statement, and the switch statement. The first of the selection control statements, the if statement, applies to a block of code and either executes that block of code or skips over the block of code depending on a condition. The condition must resolve to a Boolean value. So it could be a value, a variable, a relational operation, a logical operation, or anything that ultimately has a Boolean value, that is true or false. So over here in Visual Studio, let's create a new project and we're going to call it Selection Fun. We'll make sure we have an empty C++ project, and we will call it Selection Fun. We will wait on it for a second to create the project, and we will create our source code file, add new item, C++, main.cpp as we expect, and I will hit add. Now I'm going to fill in the skeleton code as I normally would, using namespace standard, and then int main return 0. Good. So far, so good. So, similarly to our earlier example, we're going to use an integer named age to make a decision. This time we will say, in sequence, welcome to the pub and grill, and then ask the user for their age. So let's create that variable, int age, and we're going to then write the code for welcome to the pub and grill. All right. Now we're going to ask for the age. I'll say, please enter your age. And then the user should be able to type their age in. Now we will test to see if the user is 21 or older. 21 is the legal drinking age in the United States. So we will offer the user a beer if they are 21 or older. So if the age is greater than or equal to 21, we will say, here, have a beer. Now, outside of the if statement, in sequence, we're just going to say, thanks for coming to the pub and grill. So this is going to be executed regardless of whether their age is greater than or equal to 21 or not. Now, let's run the code a couple times and test it with some different ages. So start without debugging. It says, welcome to the pub and grill. So that's the first thing that it says in sequence. And then it says, please enter your age, followed by a new line character. And it's waiting on me to enter an age. I will type in 16, which is definitely less than 21. And then I will hit enter. And it says, thanks for coming to the pub and grill. That's because what it does is it skips entirely over this if statement here that's testing the age. The condition for the if statement says 16 greater than or equal to 21, which is clearly false. I'm going to run the program again, and we're going to test it with a border condition, meaning the number right on the edge here, 21. And I'll hit enter, and it says, here, have a beer. And then it says, thanks for coming to the pub and grill. You'll notice that 21 is greater than or equal to 21. That little or equal to part is very important in this case. Now, let's run this again, and we'll try something larger. So we'll just see 25. And again, it says, here, have a beer. Thanks for coming to the pub and grill. So that's cool. Our code is getting smarter. It's either offering a beer or not, depending on the user's age. Now, let's improve our communication with the user using the if-else statement. While the if statement is a single selection control statement, meaning that it either does something or doesn't based on the condition, with the if-else statement, you can do one thing or another based on a condition. Thus, if-else is considered a double selection control statement. So let's change our code to now offer the user a Coke if they're under 21. So we'll put an else statement down here. And here's another thing. We could do it the same line or different lines. Usually for C++, I keep it on different lines, but it doesn't really matter. So see how it will say here, have a Coke. And then let's run it again with those different ages. So debug, start without debugging. It says, welcome to the pub and grill, please enter your age. If I put 16, which is under 21, it says here, have a Coke. Thanks for coming to the pub and grill. So what happened is when it tested the 16 against the 21, it knows that this statement here is false. 16 is not greater than or equal to 21. So it jumps down to the else statement. Pretty cool. Let's try it with 21 and then with 25 and make sure our code still works. So we'll put 21. Here, have a beer. And then we'll run it one more time. 25. Here, have a beer again. Good. That's pretty cool. So what if we want to tell the user something more specific if they're, say, 16 or older but not quite 21 yet? We can chain if-else statements to simulate more than just double selection. That is, to simulate multiple selection, also called multi-way selection. So we're going to modify the code to offer them a Coke and say, at least you can drive if they're 16 or higher. So in between this if and the else, I'm actually going to put an else if age greater than or equal to 16. Now what will happen is if this right here is true, it'll execute the here have a beer and skip the other two. If this one is false, it will then test this one, and if this one is true, it'll go in here and then skip the else. And if both of these are false, it will skip them both and go straight to the else. So let's see what happens here if we put here have a Coke, which is just what we do in the else as well. We could also put and at least you can drive. So that gives them a little more encouragement than just the general under 16 crowd, which is right here. So let's run the code with some different values. So we'll do this. I will put 14, and since 14 is under 21, it'll check this, and then it's also not equal to 16, and it's definitely under 16. So it'll skip that, it'll go to the else. So you notice it just says, here have a Coke. So it only puts what's in this else down here. The other thing we could test is, let's try 16 right on the dot. You'll notice that it says 16, here have a Coke, and at least you can drive. So this middle one is executed. It has skipped over the first one because 16 is not greater than or equal to 21, and it will skip over the end because it will have been satisfied by this middle one right here. Now, let's try it with 18. So 18, it'll say, here have a Coke, and at least you can drive. And then thanks for coming to the pub and grill. So now we will try it with 21, and it'll say, here have a beer, thanks for coming to the pub and grill. Pretty cool, right? Now we have so many possibilities. So the if and if else are both very useful for different circumstances, and we have seen that we can simulate multi-way selection if we chain the if-else statements. There is a third selection control statement available in C++ called the switch statement. This one is not as flexible, but naturally provides multi-way selection. So I'm going to close this project and create a new one called Grade Fun. So let's do that. File, close solution. I'll create a new project, new empty C++ project, and we will call this one Grade Fun. And I will hit Create. For this one, I'm going to create the new item here, main.cpp as usual, and fill in the skeleton code. And we're going to do some kind of interesting stuff with this. Int main and return 0. Now for this, what we're going to do is we're going to ask the user to enter a character, a char, and for each grade, we will tell them how they are doing in the class. Note that in many countries, like for my British and Canadian friends, the term mark is used more commonly instead of grade. But here in the United States, we often use the term grade or letter grade. So we're only going to allow uppercase A, B, C, D, or F. If they enter anything else, we will tell them it's an invalid grade. So let's write some code. We're going to prompt them. Well, we need char here, so char grade. And we're going to prompt them, please enter a letter grade and cin2 grade, stream extraction operator. And then what we're going to do is we're going to switch on the grade, and I'm going to put an end switch here just so you can see where the curly braces line up. And we're going to say if the case is that the grade is an A, I prefer it indented a little further there. We're going to say great job, and then we have to put a break statement here. I'll talk about that in a moment. Case B, colon, C out. We're going to say good job right there, put a break. Case C, C out. You can do better. Oh, I gotta fix a couple things here. See, it's easy to do some silly things if you're not paying close attention. These are characters, so I have to put them in single quotes. And then I'm going to put a break there. And then case D, I'm going to say, oops, 1 second here. Case D, C out. You are getting close to failing, which we definitely don't want, right? Break. And then see case F. Oops, case F, C out. You are failing the course. See, that's very serious. Can't have that. And then default is you have entered an invalid grade. Try again. There we go. The default does not need a break, and we'll talk about that in just a second. In the context of switch statements, the break statements are crucial, though. Otherwise, each of the cases would perform what is called fall through. They automatically execute everything until they reach the end or reach a break statement. So what would happen is if we put case A here and say great job, but if we didn't have the break, it would actually fall through the B and go to good job. So that can cause problems. We don't want that fall through behavior, so we put a break statement there. So as soon as it finds one that it matches, it will stop and it will not try any of the others. The default doesn't require a break statement because there's nothing under it. The default acts a little bit like an else block of code with no if statement attached, like we saw with if else, in that if all the other stuff fails, the default will execute. So if they don't enter an A, B, C, D, or F, we will go to the default, which says, hey, that's an invalid grade, and then we can end it. So let's run the app and see what we get. So I'm going to run the app, start without debugging, and it's saying, please enter a letter grade. I'll put A. It says, great job, as I expected. Let's try it with capital B, and we will try that. Good job. I'm going to try each of the cases since there's only a few of them. Oops. And we're going to do a C. It says you can do better, so it skips the A, skips the B. Oh, look, it found a C. You can do better. Then it breaks. We will try a D. You're getting close to failing. Now we can say F for failing. You're failing the course. And let's try a value that doesn't actually exist, like Q or something like that. So you've entered an invalid grade. Try again. All right, pretty good. Our program considers lowercase, even valid letter grades, just in lowercase, to be invalid because they don't match the capital counterparts. One way to handle this is to use fall through, which we'll see in just a minute, but let's see what happens if we run the app and I put, say, a lowercase a. If I do a lowercase a, it'll say invalid grade, and you might think, well, wait a minute, capital A, this right here should be the same. It should work, but it doesn't. So in this case, we're going to use the fall through behavior to our advantage. We're going to put under each of these case lowercase a, and then also case lowercase b. Going to do the same thing for C, case lowercase c, then case lowercase d, and then case lowercase f. I'm going to save that and run it again, and let's see what kind of behavior we get. So if I put a capital B, for example, I get good job. Now what happens if I do a lowercase b? If I do a lowercase b, it still says good job. Excellent. That's what I wanted. And as we did earlier, an A, great job, even if it's lowercase. And then what about something invalid? Whether it's uppercase or lowercase, if I put a Q or an E or a Z or something like that, it'll say you've entered an invalid grade, try again. So whether it's uppercase or lowercase, it doesn't matter if it's not one of these valid values. Now there's other ways to handle this, like you could do a conversion, make sure it only tests capitals or things like that, but there's so many different ways to solve the same problems, we're not going to ever have time to go through every possible solution. So now I have a little challenge for you, and I want you to create a brand new project. In fact, I think I'm going to start it. I'll create the project with you. We'll close the solution. I'll create the project, empty project, next, and we're going to call it Retired Women. So Retired Women. It'll make sense in just a second. So this brand new project, which we will create a nice new skeleton file here, main.cpp, include iostream using namespace standard int main, and then return 0. For this project, it's going to be a program that prompts the user, so we're going to say prompt user for age and gender. So age is int, gender is a character. So what's going to happen is they qualify for the Retired Women's Club discount only if they have a gender value of F or F and are 60 or over. My biggest hint to you is use relational operations or logical operations to see what we can do here. Now, what you're going to print, if they do qualify, you'll say you qualify for the discount or you do not qualify for the discount. So what I want you to do is pause the video and try this yourself. You can use any of the selection control statements that we've gone over so far, and I may not come up with the exact same solution as you, and you may not come up with the exact same solution as me. It doesn't really matter. So come back when you've completed this, or if you need some help. So how did that go for you? Did you complete the challenge? Let's do it together and see what we come up with. You may not have done exactly what I'm about to do, as I said, but that's usually okay. The more complex these challenges and projects get, the more likely it is there will be differences between our code. So we're going to complete this. So first I'm going to create an integer for age, and then a char for gender, and then we're going to say, please enter your age, and then that goes into age, and then please enter your gender, cn to gender. And then what we're going to do, again, the statement that we made earlier is that if the age, or if the gender is equal to capital F. Now, most people are tempted to do this, but this is not going to work, because that's kind of the way we would say it in English, if you're capital F or lowercase f. But we can't just do that. So you have to actually do this. We have to say, or gender is equal to F. And there's another thing we have to do. Since this has less precedence than the and we're going to have to use that, I actually have to put this in another set of parentheses. And it'll also clarify it. So I'm going to say if the gender is female, we're halfway there. And we'll say age greater than or equal to 60. So now this means that they qualify. Otherwise, they do not qualify. Okay, so right here we'll say you qualify for the discount. And then otherwise, if they're not a member of the Retired Women's Club, you do not qualify for the discount. Perfect. Excellent, excellent. So if they are either male or not at least 60 or neither, this is going to take it down to the else statement. Otherwise, it'll execute the you qualify for the discount. Awesome. So let's try this. We're going to try it with a couple different options here. So we will run this. It says, please enter your age. So we're going to try it with 62, and we're going to put female. So it does say, in fact, you qualify for the discount because they are 62 and female, which is both greater than or equal to 60, and it's one of these genders right here, the gender options. So we're going to start without debugging again, and this time we're going to switch it up a little bit, and we're going to say 62, so age-wise they qualify, but what if their gender is male, M? You do not qualify for the discount. Now, do it again, and we are going to say, what if they are 50, so already they're not going to qualify, and male, don't qualify. What if they're 50 and female? So let's try that. So we'll say 50 and female. Don't qualify because of the age, right? So, excellent. Now you have some stronger foundations for the selection control statements, if else, and switch. Before we move on to the next lecture, can you remember all three categories of control statements? That's it. Sequential, selection, and repetition. We discussed sequential as the default control statement, and we just got done discussing selection in this lecture. In the next lecture, we will discuss how we can get our programs to perform repeating behavior. I'll see you there.